Number 1, for the function f of x equals 2x cubed minus 5x squared plus 7x plus 2, find f double prime of x, that is, find the second derivative of f of x. Then find f prime of 0 and f prime of 4. So f prime of x would be 6x squared minus 10x plus 7. F double prime of x would be 12x minus 10. So the second derivative of the function is 12x minus 10. Now they ask us to select the correct choice below and fill in any answer boxes in your choice. Well, f double prime of x is defined as 12x minus 10, so f double prime of 0 is just 12 times 0 minus 10. So it definitely exists. It's negative 10. Now f double prime of 4 is the second derivative at the value 4. So that's going to be 12 times 4 minus 10, which is 48 minus 10, or 38. Number 2, for the function f of x equals x squared over 2 plus x, find f double prime of x, then find f double prime 0 and f double prime 5. So find the second derivative, that is the derivative of the derivative. So we have to start with the first derivative, and it's the quotient rule. The denominator, 2 plus x, times the derivative of the numerator, 2x, minus the numerator, x squared, times the derivative of the denominator, 1. So denominator, derivative of the numerator, minus numerator, derivative of the denominator, over the denominator, squared. Going to clean this up a little bit, simply because it'll make the second derivative easier to take. So I'm going to distribute this 2x and get 4x plus 2x squared minus x squared over 2 plus x quantity squared. That reduces further to 4x plus x squared over 2 plus x quantity squared. Now I could factor out an x from that numerator, but that would make it a product, and it would just have to use the product rule. So since this is f prime of x, I'm going to use it to find the next derivative. It's going to get a little bit longer, a little bit tedious, but you just have to take it slowly. Using the quotient rule, we have the denominator, 2 plus x quantity squared. Derivative of the numerator, 4 plus 2x. Minus the numerator, 4x plus x squared, times the derivative of the denominator, 2 times 2 plus x, and then the derivative of the base inside there would be 1, so we don't have to write that. And all of that is over 2 plus x quantity squared, all squared. Now to make this a little bit easier, I'm going to look for a common factor up here, and I think I'm going to take a 2 out of this. So this cleanup is probably harder than the actual derivative. You can test MyMathLab to see what it will take, and I'll be looking for this on your work, but you don't have to simplify it unless there's a need to simplify. If we needed to set this numerator equal to 0 to find where it was 0, we would definitely have to simplify. So I'm just looking for things that might help me. I've got 2 plus x squared. I can take out a 2 and get another 2 plus x here. I'm going to move that 2 and 2 plus x to the front. And then I'm going to have a 4x plus x squared. And all of that is over 2 plus x to the fourth. Now, doing that made me realize that, look, both of these have a 2 and 2 plus x. So that's a common factor. I'm going to factor it to the front, 2 and 2 plus x. And that's going to leave, and I'm going to need a bigger bracket here, 2 plus x squared. See, this one's come to the front. This one's come to the front, minus 4x plus x squared. And all of that is over 2 plus x to the fourth. So let's see, I'm going to leave my 2 and my 2 plus x. I'm going to reduce it with the denominator eventually. I'm going to focus on what's in here. This means 2 plus x times 2 plus x. So that's going to give me 4 plus 4x plus x squared. And this minus has to be distributed. So that's going to give me minus 4x minus x squared. And all of that is over 2 plus x to the fourth. Now it's about to simplify drastically because 4x minus 4x, x squared minus x squared, I am left with, on the top, 2 times 2 plus x times 4, because the only thing left in here is this 4, and that's over 2 plus x to the fourth. And now since 2 plus x and 2 plus x are factors, those can divide. It would leave 3 of those on the bottom. My numerator will be 8, and my denominator will be 2 plus x to the third. So this is definitely a lot easier to evaluate than this. Okay, I can easily plug in my values now. So first I'm going to type in my derivative as 8 divided by 2 plus x to the third. Right? And now I can find f double prime of 0 just by plugging in a 0, 8 over 2 plus 0 cubed. Well, that's going to be 8 over 8, which is 1. So f double prime of 0 is positive 1. And now I can find f double prime of 5, doing the same thing. Okay, that's going to be numerator 8 over 2 plus 5 cubed. That's 8 over 7 cubed. So I'm going to grab my calculator real fast. 7 to the third power is 343. So 8 over 343. So hopefully that's reduced. It will tell me if it's not. And it was. So the moral here is this part is the calculus. That's what I'll be looking for on a test. All this cleanup makes it a lot easier to do the evaluation, and ultimately you might need to do this later to do some kind of an application. Number 3, for the function f of x equals the square root of x squared plus 1, find f double prime of x. Then find f double prime of 0 and f double prime of 6. Of course, that means find the second derivative. The first thing I'm going to do is I'm going to write my square root with a fraction. So instead of the square root of x squared plus 1, I'm going to have f of x is x squared plus 1 to the 1/2 power. F prime of x is going to be the power times the base to the power, subtract 1, I'll go ahead and write that 2 over 2, times the derivative of the base, which is 2x. cleaning this up, this 2 in this denominator and this 2 in this numerator will reduce. I will get x squared plus 1 to the negative 1/2 times x. And now I'm going to rewrite that x over x squared plus 1 to the 1/2. Now, normally I might write that with the square root in the bottom so that I would know I need to take a square root, but I need to take the derivative again, so I'm just going to leave it with the fractional power. So to take our second derivative, we're going to be dealing with the quotient rule. So we take our denominator, x squared plus 1 raised to the 1/2, times the derivative of the numerator, which is just a 1, minus the numerator times the derivative of the denominator, 1/2, times x squared plus 1, times 1/2 minus 1, negative 1/2, times derivative of the base, 2x. And I really don't need this parentheses right here. I'm just going to erase that and put in a multiplication right there. So look, again, it's the numerator, derivative of the denominator is the power, the base, the power minus 1, and the derivative of the base. All of that, even though I'm going to need some cleanup there, is going to be x squared plus 1 to the 1/2 squared, because you have to square your denominator when you use the quotient rule. So look what I have. I have x squared plus 1 to the 1/2. That's this first part. Over here I have a 2 in the bottom reducing with a 2 in the top. I have an x and an x, so that's going to be minus x squared. And all of that is x squared plus 1 to the minus 1/2 all over. And when we multiply these two, we get a 1, so it's just over x squared plus 1. Now, you got to be really careful here. You can't just move this to the denominator now because of this subtraction. So what I need to do instead is I need to factor out what they have in common. And you'll notice they both have an x squared plus 1. And I can either factor out the 1/2 or the negative 1/2. And it's easier if you just factor out the negative 1/2. So if I factor out a negative 1/2 out of a 1/2, now remember that these exponents, negative 1/2 plus some number has to add up to positive 1/2, because when you multiply, you add exponents. So whatever I put for the exponent here of x squared plus 1, I have to add it to negative 1/2 to come up with the original 1/2 that's right here. So I'm just going to go as a side. What does that mean? It means the question mark is going to be a 1/2 plus a 1/2. So that's just going to be a 1. Now, out of the second one, it's easy because we took out the negative 1/2. So we've taken out this whole factor here. This whole factor has come out. So the only thing that's left is the minus x squared. And all of that is over x squared plus 1. So if I reduce what's in the, and by the way, I can now take this guy to the bottom because he's being multiplied. Look, right in here, there's multiply, not add. So he can, that term can be moved to the bottom, or that factor can be moved to the bottom. So I'm going to put that x squared plus 1 to the 1/2 down here with the x squared plus 1. And all that's left is to deal with this, and this x squared and this x squared are going to reduce out. My numerator is a 1. So remember, I have to add these exponents. So it's going to be 1 over x squared plus 1 to the 1/2 plus 1, which is 1 over x squared plus 1 to the 3/2, which is 1 over the square root of x squared plus 1 cubed. That's a property in algebra that x to the n over m is the m root of x to the n. Okay? So whatever the root is, goes here. Well, that's a square root. That's this denominator. And then whatever this upper part is, that's your exponent. It goes here. So that should be our answer for the second derivative. 1 divided by, and I am sure that it'll take it to the 3/2, so let's do it that way. X squared plus 1 to the 3/2. But when I want to take the square root, I need to know I'm taking a square root, so that's why I'm going to go ahead and put it like this with the radical. I need to find f double prime of 0, so that's 1 over the square root of 1 cubed. Look, if that's a 0, that's going to be a 1 cubed. That's 1 over the square root of 1. That's going to be 1. Answer here is 1. Now in the next part, they want me to find f double prime of 6. So that's going to be 1 over 6 squared plus 1 to the 3/2. So that's 1 over the square root of 37 cubed. It's going to be a tiny number. 1 over the square root of 37 to the third is 50,653. So that's 1 divided by, let's go several decimal places so that 50653, the square root of that is 225.0622. I'm going several decimal places so that I can round it and still get it right. So 1 divided by 225.0622 is about 0.00. So this is going to be basically 0.